Good morning or good afternoon, depending on when you guys get to this video today. So as I said in the last class, I'm going to post something that just kind of finishes up our 4.4 notes. So go ahead and get your notebook out. And I'll keep this short and sweet. You guys won't have an assignment. It'll just be jotting down this last bit of information. Okay, so 4.4 finishes up with something called the factor theorem. And it is this, and you can pause it. I'm going to kind of move through this. So if you write faster, you can go faster. But basically, it says that something is a factor of a polynomial if and only if, which means it works both ways, the remainder is 0. So when you plug something into, right, that's what they're doing here. They're plugging k into a function. And when you do that and get an output of 0, that means that there's nothing remaining. So it goes into it evenly. That's what the factor theorem says. Again, pause if you need to, but I'm just going to go through to the next page. Okay, so we're going to look at two different things here. We're going to determine whether a polynomial, whether this binomial x minus 2 is a factor of this quadratic. And then we're also going to look at when it is a factor, if you look at part B, when x plus 5 is a factor. So it's already telling me that when I plug x plus 5 into this polynomial, it will go into it evenly, which means I should get a remainder of 0. Then we're going to work on factoring stuff that's left over. Okay, so that's what we're going to kind of finish up with. All right, so the first one, when we're talking about things being factors, we're going to go back and use synthetic division. So if I'm trying to plug in x minus 2 into this polynomial, I'm going to put positive 2 outside the box, right? It's always the opposite of what this factor is. And then inside the box, I put the coefficients of all of these terms, which happens to be 3 terms in this quadratic. So I'm going to put 1, then 2, then negative 4. And I'm going to do the synthetic division process. Long division would actually work here also. I don't think anyone's choosing long division over synthetic division, but if you did, it would work. What I'm looking for here, because it's asking me to determine whether x minus 2 is a factor, I am going to hope that the remainder, remember, which always happens here in this last column's answer, I am hoping for a remainder of 0, right? That's ideal. If I get a 0 here, then the answer to this question is yes. X minus 2 goes into this polynomial, this quadratic, evenly. So we call that a factor, right? So let's go through and see what we get. We drag out the first number. The synthetic division process is not changing. We do 2 times 1, which is 2, add that column, multiply 2 times 4, add that column, and we get 4 as a remainder, which means this is not a factor, right? If it was a factor, then it would have a remainder of 0 because it goes into it evenly. That's the definition of the factor. All right, example 2, same question. We won't get to the other kind until the next page. I'm going to plug in x plus 5, which when I do synthetic division, I plug in negative 5 outside the box. And then inside the box, I'm going to put each of these coefficients in order. And remember, if we're missing a term in this polynomial, right, it starts with a 4 power, then it goes to a 3 power, then it goes to a 2 power, and it's missing the x to the first power term, I need to put a 0 in its spot. So I'm going to have a 3, then a 15, then a negative 1, then a 0 because I'm missing x, and then 25. And I'm going to do the same thing I did before. I'm going to go through the whole synthetic division process, and what I'm looking for or hoping for is a 0 here at the end. If I get a 0, then that means that x plus 5 is a factor and it goes into this thing evenly. So we drag out 3, we multiply it, add, multiply, add, multiply, add, multiply, add. And there we got a factor. So this time it is yes, x plus 5 is a factor. So that's how you determine if a polynomial is a factor of another polynomial. You can use either long division or synthetic division. Obviously, synthetic division, when they're in this form, is a better choice. And when you get a remainder of 0, it shows that the term you plugged into the polynomial is a factor. Okay, so that's part 1 about factor theorem. Part 2 is putting that idea together with what we were doing the last couple classes, which is this whole factor it completely process. Right, so we're going to do the same thing, but notice, like I was saying on the page before, it's telling me this time, show that this thing is a factor. So it's telling me right off the bat that this is going to give me a remainder of 0 because it's saying it is a factor. So I'm going to do the process, and I know I'm going to get, let me just write it out here, I guess. I know I'm going to get a 0 here. But what I'm going to do now, because it's asking me to factor this whole thing completely, I am going to take what's left in this portion and use that to factor. Right, so that's kind of the steps here. All right, let's set it up. I'm going to plug -3 outside because it's x plus 3, so I plug in the opposite of that number. And then inside here, I'm going to put all the coefficients. I have x to the 4th power, x cubed. I'm missing an x squared term, so I am going to need a 0 there. Then x, then number. So 1, then 3, then 0, then -1, then -3. Don't forget those zeros if you're missing a term. I'm going to drag out the 1, multiply, add, multiply, add, multiply, add, multiply, add. Okay, pay attention because it told me that it was a factor. So if you do all this work and get something other than 0, erase and start over because you did something wrong. You are supposed to get 0 when it's worded this way. All right, now I know it's a 0, so I know that x plus 3 is a factor of this polynomial. Now I have to figure out what's the other portion that I multiply to get that. And that answer is right here. This is your constant. Remember how we labeled this last section when we did division? Remainders in the box, then it goes constant, then it's your x term, then it's your x squared term, then it's your x cubed term. So I know that x plus 3 goes into it evenly, and I also know that what's left over here also goes into it evenly, so I'm going to put x cubed minus 1. And now I'm going to take this piece that's left over and factor it using either the AC method, the pairs process, difference of 2 cubes, sum of 2 cubes, difference of 2 squares, grouping, right? All those choices that we now have. And this is a difference of 2 cubes look, because I can rewrite 1 as 1 cubed. I know it's silly to do, but I do encourage you to write it like that. And then I'm going to apply the pattern. So A is x and B is 1. So this is going to be your fully factored polynomial. I know that x plus 3 is a factor because they started me with that. Then I'm going to use the pattern here, which is going to say A minus B times A squared plus A times B plus B squared. And remember, as soon as you use the pattern, you can never reduce again. So that is your fully factored polynomial. using this synthetic division step. Eventually, just to give you a heads up, next week when we move into the next section, they're not going to start you with a factor. So we're going to have to come up with options and then start this whole process on our own. All right, I'm not going to go through a story problem or anything right now. We're just going to get through the basic notes. All right, so I would like you to pause this video, do these two examples on your own in your notes, and then come back to the video and check your answer. Okay, so pause now, work on these two, and come back. All right, so the first one is determining whether it's a factor or not. So you're just checking. So you're going to plug in +4, and I'm looking to see, is my remainder 0 or not? So my coefficients are 2, 5, and -12. This will be your remainder location. If it's a 0, then it's yes, a factor. If it's not 0, then it's not a factor. Drag out 2, multiply, add, multiply, add, and we get a remainder of 40, which is nowhere near 0. So that means no, not a factor. For number 11, it's like that second problem where it's saying this is a factor. So you are going to plug in 6. You are going to get 0 here because that's what should happen. And you're going to take what's left in this portion down here and completely finish factoring with this factor x minus 6. So I'm going to plug in 1, -5, -6. I am missing a constant term, so I need to finish my row with a 0. Take out the 1, multiply, add, multiply, add, multiply, add. Okay, so I know I did it right because I did get a remainder of 0, as I should. Now I know that x minus 6 is one of my factors when I'm factoring this polynomial. And now that I did this synthetic division process and got a remainder of 0, I also know that this stuff makes up the other factor. So this is your remainder, this is your constant, this is your x, and this is your x squared. So 1x squared plus 1x, notice I didn't put the ones in front of those x's, and that's fine, you don't need to do that. This is my other factor. So now, just like I have been doing with all my methods, I know this term is done because it's linear. Now I have to look at what's left over here and see if I can factor this down. And hopefully you notice they both have an x term. So I'm going to take a common term out of these two, which is an x. And when I take x out of x squared, you're left with an x. And when I take an x out of an x, you're left with 1. Now I'm finished. All right, now I have them all simplified. This is kind of silly. You should never have some x in the middle. So we're going to move the x in the front, and then x minus 6, and then x plus 1, right? Technically, it doesn't matter what order you write your terms in because you're just multiplying, and the associative property lets you multiply stuff any order you want. But it looks silly when there's just a single x term squeezed in the middle. So you usually put the monomial stuff in the front. All right, so now that you replayed this and you already checked what you did, hopefully you got those right. We'll pick up next class with the same idea and do a bunch of reviewing stuff from all of these different factoring methods. Have a great rest of your day. I'll see you either Thursday or Friday.